In this video, we're going to see how to do nonlinear calibration in RSpec. When I click on Calibrate, there's a new nonlinear tab. And this tab brings up a screen that has a grid with pixels and wavelengths. Let's do a 2-point calibration first. I'll click on the pixel, and then I'll enter the wavelength. In this case, it's the 0-order wavelength. I'll hit the Tab key to move to the next field. Now let's put a second point in. Over here, I'll click on the pixel and then put this wavelength in, which we know it's a hydrogen bomber feature. So we'll put that wavelength in, hit the Tab key again. Now when I click Calculate, RSpec draws a line between the 2 points in the graph area, and it shows us that the RMS error is 0.0 because we can always draw a line through 2 points. Clicking on the Apply button does a calculate and applies the numbers on the left, calculating the spectrum over here. If we hover over the spectrum, we can see that it's been calculated in angstroms. Now let's add a third point out here. I'll zoom in with the roller wheel on my mouse, which is a good way to zoom because it preserves the aspect ratio so the features remain visible. Now for the pixel, I'll click on the pixel, and in this case we know that it's 6562, but here I'll put in 6582 just to make a little bit of a mistake. There's the point. We can see they're on a straight line when we calculate. Not quite a straight line. We have a tiny bit of residual error. I'll click Apply, and those 3 points will be applied to the profile for a calibration. To guarantee a fit through 3 points, we click on the second order radio button, which will calculate automatically, and we can see that the error goes to 0. Once again, clicking on Apply calibrates the spectrum with these numbers. Now this is a neat feature to show you. I'm going to put a check mark in this checkbox. Now, whatever row I'm located on here in the grid, RSpec over on the right, we can see, as I move through the rows, will draw a vertical line showing the feature. This makes it much more easy for you to locate your calibration lines as you're working with them. Let's put in another 4th point. I'll come over here, and for the sake of example, I'm going to put in a pretty high wavelength. We'll put in 10,000, which is too big. Now when I click on Calculate, the software tries to draw a second-order polynomial through those points, and it's unsuccessful. You can see that we have a fairly high RMS error. However, we can go up to a third-order polynomial, and now we can see a line going through those points. However, this is a good example of where going too high in the polynomials, although you'll get a perfect fit, acts in a way that isn't accurate, especially at the ends of the spectrum. So having this visual display can be very helpful to determine your fit. Now there are a lot of right-click options on the grid, and I'm just going to delete that line. Now suppose these wavelengths, because they're typical wavelengths, you plan to use frequently. What you can do is come down here and click on Save, and then save these in any folder that you want with a name that's self-descriptive. So we'll make it Hydrogen Bomber, and click Save. Now let's clear the grid, as if we're coming in for the first time today. Now if I click Reload, it will reload the most recently saved wavelengths, like that. Now, although it's not frequently used, if you hold the Shift key down and hit Reload, you get the pixel numbers too, which can be useful again when you're testing and experimenting with the program. So now that we've seen one way of entering nonlinear data into the grid here, let's look at an alternate method that can be faster and somewhat more accurate. Now first I want to turn off the calibration. It makes it a little easier to follow. So the easiest way to do that is simply to close and then reopen the Calibrate screen. So now we're in pixels. Next I'm going to erase the entire contents of the grid so that we're starting from scratch on this screen. And I'll also turn off this checkbox to make things a little more easy to see. Now we saw a moment ago that to enter pixels here, we could either type them in or we could just click on the pixel on the screen. Here's a way that's a little faster and a little bit more accurate. I'm going to turn on the measure lines, like this, and then all we do is to round the feature with the measure lines. RSpec does what's called a barycenter calculation, and will show us down here that the center of that feature is 35.1 pixels. Now we could type that 35.1 into the nonlinear grid, or just click on it and enter the wavelength here, followed by the Enter key. So now we've entered our first pair of points. Let's do another one. I'm going to drag both measure lines across the screen by dragging one while the Shift key is held down. And then I'm going to zoom in by holding the Shift key and boxing in the area. Now to get the barycenter pixel of this feature, I simply surround it again with the measure lines. Now we saw in a previous video that RSpec, if I hold the Control key down like I just did, will snap the other measure line so that it intersects the curve at the same level. And down here we can see that the peak barycenter is 431.1. I can click on it. I can enter my wavelength here. With the Enter key, I've now entered my second point. If you had additional points, you'd continue to add them using the same steps that you've just seen, using the barycenter function and the measure lines. Now, since we made this video, there's been a minor enhancement that we wanted to show you here. We've added this new residual column. Let's add a third point to our grid here so we can see how that works. I'll zoom in here and select the point, and then rather than the correct wavelength, we'll put in a wavelength that's a little off so that we can see how the residuals work. Normally you'd put the most accurate wavelength in you could. When I click on Calculate, we can see that the residual column is showing us the number of angstroms off that our calibration is when trying to match those specific points. Now when we go to second order, of course, we get an exact match and the residuals go to 0. This is a tool that will let you see exactly how your calibration is working on a point-by-point basis rather than using the RMS value at the bottom for a composite error result.